All right. Now it's time for surface area of prisms. Now, it's exactly what it sounds like. It's the area on the surface of a prism. And you got to add all the sides together in order to get the total amount of area of all the sides of a prism. That's why it's called surface area. We're going to start with something simple, like a perfect cube. You know, I think of like when you get earrings in an earring box and you open up the cube, but you want to wrap the present for like mom on Mother's Day, let's just say. You need the perfect amount of wrapping paper to cover the surface of this cube, okay? Of this perfect cube box earring set, let's just say. Well, you know how when you wrap a present and you fold up the sides and you put a crease there and you tape it and there's an overlap? There is no overlap when you're talking about the exact amount of surface area for this cube. Okay, you need the exact dimensions so you can have the exact amount of surface area with no overlap when you wrap a present. It's also called nets. So you need to use a net in order to discover what the area is of each side and then add them together to get the surface area. Okay, so let's just start it. I want you to go ahead and draw a perfect cube. Okay, best you can. I'm not really using my graph paper for this, but once you draw a perfect cube, you need to know the height of that cube, which I'm going to say is 5 centimeters, the width of the cube, 5 centimeters, and the length of the cube, 5 centimeters, because it's a perfect cube, right? All sides are the same dimensions. Well, you got to just know the formulas for solving for the area of all your sides. If I know that the back of this cube is going to be length times width, because that's the area of a square, is length times width, that's 5 times 5. So the area equals 5 times 5. My area for that back is 25 centimeters squared. But that's not the total amount of surface area. Okay? Yes, the back is 25, but all the other sides are also 25 centimeters. This is 25, 25, 25, 25, 25, 25. You need to know also how many sides make up your prism. So the shortcut of drawing so like think about a cube. If I were to roll this as a dice, there's 6 sides on a dice. I know that because it only goes up to 6 on a dice, right? So if you were to draw the net of this cube, you would draw some perfect squared sides. It has 6 sides. A cube has 6 sides. All right. And then this right here, what I'm drawing, is the sides of that cube. So if the back is 25, and you were to fold that up, and then this side and this side, here's this side, and then the top, you have 25 centimeters for every single side when you see it in a net. Again, this is called a net. And this is for a cube, what to do for a cube. You add all the sides up. Or you can just ask yourself, what's 25 times the 6 sides? Your total amount of surface area would be 150 centimeters squared. Remember, we're going back to squares because I want to know exactly how many perfect squares make up that side. Okay? That's solving for the surface area of a cube. I want to know how many sides make up, or how many squares make up each side. That's why we label it, again, squared today. Now, it's not always for a cube, and it's not always going to be that easy, and you add 25 6 times. There's also your rectangular prisms. And rectangular prisms, you're still using length times width. Let's go ahead and draw it real quick. So if you were to draw a rectangle, it'd look like this, and then connect the edges. I'm going to say that this square over here, the rectangle really is going to be 4 inches high, 2 inches wide, 10 inches in length. So you're not using length times width times height. You're not solving for volume. You're solving for the area of all the sides. I'm going to go ahead and solve for the base sides real quick. That looks like 4 times 2. So 4 times 2 is 8, because remember, you're using the formula for solving for the area of all these sides. We're using length times width because they're all squares and all rectangles. So we're going to be using length times width for all these sides. But the dimensions are what's going to change. So if this side's 4 by 2, this side is also 4 by 2, which means this one is also 8. So the bases are 8, or I should say the sides. That's another 4 by 2, which is 8. So side 1, side 2. The base, remember, is what's on top. Okay, so I'm going to go ahead and see. You got to be able to visualize this. This edge is the same as this edge. You got to be able to fill in missing dimensions. So if down here's 2, up here's also 2. This is also 2, 2. And then what's this guy? Well, if this guy down here is 10, this guy up here is 10. So for the bases, the top and bottom, you're going to do 2 times 10, which is 20. That's the top base. 2 times 10 again equals 20 for the bottom base. Okay, so there's the top, the bottom, and now you got to consider the back and the front. Okay, so the back and the front, the missing dimensions looks like it's going to be 4 by 10 for the back, which is 40, and then the front, which is also 40. Now that you have the area for all the sides of this rectangular prism, how many sides? It's the same as a cube, it's just different measures. It's 6 sides. Do we have 6? 1, 2, 3, 4, 5, 6. We do. So now all you got to do is add all these together to get your total amount of surface area, which is 136 inches squared. Remember, you're solving for how many perfect squares actually fit on the or not on the inside, fit on the outside of this prism, rectangular prism. I'm going to show you one more example, and it's of a triangular prism. It's a triangular prism because the bases are a triangle. So you guessed it, we're not just going to use length times width for this part. We got to use 1/2 times base times height for this part. So that was number 1, the cube. Number 2 was the rectangular prism. Number 3, I'm going to turn over my paper so I have more space, is going to be the triangular prism example. Let's go ahead and draw it. Okay, it's like a tent. I always like draw the triangle first and then another triangle kind of off in the distance up here. The top, the back, the front. There we go. I'm going to go ahead and say that the height of this triangular bases triangle is 8 millimeters. The base of this triangle is 15 millimeters. This right here, the length of it is 19 millimeters. And now I got to give you one more, the lateral height. And this is where it gets tricky. The lateral height, okay, of the triangle is 17 millimeters. Now, you need to just know all these measurements to fill in the rest that's not there. So if this one's 17, that means this one's 17. The height of this base triangle is 8. That means the one over here is also 8. The base over here is 15, so the base over here is 15. If this one's 19, this one's 19. You got to be able to visualize the missing dimensions. The area for a triangle. Let's solve for the area of this triangle, which is 1/2 times base times height. So let's go ahead and solve for that guy first. So that is 1/2 times the base, which is 15, times the height, which is 8, and 15 times 8 is 120. Half of 120, or 120 divided by 2, whichever one you want to do, is 60. So area equals 60 millimeters squared for just the bases. So I'm going to go ahead and list this off to the side because we're going to add them together later. We have 60 for the first side, base. 60 again for the other side, 2 base. And now let's go ahead and solve for, you want to solve for the back? That'd be this back part right here. So if you're looking at it, that's back here. You can visualize it. It's back here. Let's solve for the back, which will also give us the front. So that looks like it's going to be 19 by, so if this one's 17, this one's 17, this one's 17. So we got to use length times width because it's the rectangle. And again, that's 8 times 19, which area is 152. So 152 for the back is what we have. And now we also have for the front, which is right here. So we have the front or the back. Now we got to add that same to the front because it's the same dimensions. So 152 for the front. And now let's do the bottom, which looks like it's 15 by 19. And that's another length times width because the bottom is a rectangle. So 15 times 19. 15 times 19 is 285 for the bottom. There's no technically top because it goes to a point there on the edge. Let's go ahead and add all these together. You got to add all these sides now. So 60 plus 60 plus 152 and 152 plus 285 equals 709 millimeters squared for your total amount of surface area. So go slow with this stuff. I will say right triangular prisms are even a little trickier. So if you see one of those, make sure you just be able to maybe draw it out and shade in the sides as you go. Nets are also helpful, which I'll provide for you in a later time.